Every function in MATLAB has code behind it. You can investigate this code further by typing edit space and then the function name in the command window. This will pull up that function and some of the information about it. You can read the code there. A lot of the functions have the code hidden because you can't see the details since they're copyrighted by MathWorks. For string to double, you can see some of the details about the function. So whenever you use the string to double function, it's running all of this code. You are going to learn today how to create your own functions like this. The first thing you need to do for writing a new programmer-defined function is open up a new script file. The first word will be the word function. Whatever you choose for your script file name needs to be the same as your function name. Your function will have input parameters, which can range from no input parameters to many input parameters. And it will have return variables. Again, it can have no return variables or it can have many return variables. At the beginning of your code, I recommend adding comments to describe the function and how to use the function, and then also credit yourself. When running a function, you need to understand how it passes the data. First, when I call a function, I give it inputs. These go into where the input parameters are. The code then runs using those input parameters and defines the return variables, and then the return variables are reported out. First, you need to create a main script file and our first programmer-defined function script file. The first programmer-defined function that we are going to create is a function for the Pythagorean theorem. So again, our function is going to be the Pythagorean theorem. We are using the two sides A and B to find the hypotenuse C. Here's an example of what it should look like at the beginning. So again, you have the function, you have your return variable equal to the function name and your input parameters. And then you have your documentation commented in. If you type help space the name of your function, then you will see your documentation show up in the command window as shown here. Then we need to write the content of your function. So in this case, hypotenuse is going to equal the square root of side A squared plus side B squared. It doesn't matter what you decide to name your variables as long as they are consistent throughout your function. Now we are going to call this function in our main script file. Notice how in my main script file I'm using variables opposite and adjacent. It's okay to use different variable names in the main script file compared to the programmer-defined function. The way that you're calling the function, it's important that you have the placement consistent. So my opposite is my side A, and the adjacent is the side B. Calling functions, it's all about the placement of their variables, not the variable names. Now we are going to create our second programmer-defined function. The purpose of this function is to display the results. So again, the function is displaying results. Our input arguments are going to be the solution or the results that we want to display. We will not have any return variables for this function. So again, we will start with the first line in the documentation. Now we will write the content of the function. So based on the specifications, we need to have the output outputted with %d for whole numbers and outputted using the %f placeholder when I have decimals. So this will now do that. Now we are going to call the function in our main script file. So notice I no longer have an fprintf in my main script file. Now I'm just using my display function. This is our last programmer-defined function. Now we are going to create a programmer-defined function that are going to error check the user inputs. So again, the function purpose is error checking. My input arguments is going to be the variable that's being error checked. I actually have two different variables I will be error checking, but I will only look at one at a time inside the programmer-defined functions. And then the return variable will be the variable that was error checked. So again, I'm taking variable a in, for instance, and then outputting variable a after it's checked. So again, starting with the documentation in that first function line, then writing the content of my function. Again, here you will notice I'm not looking at a specific variable, I'm just looking at variable, in this case val, and that's the variable I'm going to validate or error check. And then I have the while loop that's checking variable val, and then I'm outputting that same variable. So now I'm going to call this function in my main script file. So I will call this function both for looking at opposite and adjacent. So I'm using that same function 2 different times in my script file. This is an example of how you can put code into a program-defined function and run that same code multiple times in your code without having to copy and paste the code or rewrite the code.